joyride, a hit and run. I thought I loved you and you thought I was.
So what is hydraulic jump? Hydraulic jump is a phenomenon that occurs when a supercritical flow suddenly changes into the subcritical flow, causing a rapid rise in a water depth. This process produces a turbulence and dissipates a significant amount of energy. Hydraulic jumps commonly occurs in open channels, spillway, canal, and dams. Studying hydraulic jump is important in hydraulic engineering because it helps engineers understand flow behavior, reduce erosion, and design hydraulic structures that are safe and efficient. In this experiment, the hydraulic jump phenomenon is observed in a rectangular plumb by measuring the flow characteristic and analyzing the relationship between flow rate, water depth, and jump length. Oh yeah, the objective of this experiment is to study or visualize the characteristic and the behavior of a hydraulic jump in a rectangular plumb, including its location, jump length, water depth, and energy dissipation. To determine the relationship between the flow rate, initial and the final water depth, and jump length for predicting and improving the design efficiency and safety of hydraulic structures such as spillways, canal, and dam.
In hydraulic system, water flow at a very high velocity can suddenly increase in depth, creating a phenomenon called hydraulic jump. This sudden change causes turbulence and dissipate a large amount of energy. If not properly conducted, it could lead to erosion, damage in channel, reduce the stability of hydraulic structure. Therefore, this experiment is conducted to study the hydraulic jump by measuring parameters such as flow rate, water depth, energy loss, and Froude number. A hydraulic jump occurs when fast-moving shallow water, known as supercritical flow, suddenly change into slower-moving, deeper water called subcritical flow. This usually occurs downstream of a sluice gate, where the water velocity is high. During the hydraulic jump, excess energy is dissipated through turbulence, making the flow more stable, helping to prevent erosion. This principle is widely used in hydraulic structures such as spillway, dam, and channel.
The apparatus that we use in this experiment is, first we got sluice gate, next we have tailgate and vernier caliper, next we use hydraulic bench, rectangular flume, and lastly we have point gauge. That's all.
First of all, we turn on the machine switch. After that, we adjust the position of the sluice gate in the correct state. Then, place the tailgate on the end of the flume. Then, open the valve to release the water. After the water has come out, we measure the width of the flume. After the water has stabilized, we measure the height of the sluice gate. Then, we measure the height of Y1 and Y2 using point gauge. After everything was measured, we cover the hole with the ball to record the flow rate and the time. All the steps and measure repeated in 3 times with different height of sluice gate and tailgate. So now we move to the data analysis. Here is all the result. We measure the flow is 0.079 meter, and we use a different height of tailgate and 3 different height of sluice gate. Before that, let me introduce Y is referring to height of water before the gate. Y1 is referring to the height of water after the gate. Y2 is referring to the height of water after the hydraulic jump. Firstly, we need to calculate the flow rate by using this formula. After that, we need to calculate the velocity 1 and velocity 2 by using this formula. Third, we need to calculate the Froude number 1 and Froude number 2 using this formula. Lastly, we need to calculate the specific energy 1 and 2 using this formula. Here is all the results.
So, Akil, what improvement can we make to get more accurate results?
Okay, there are several improvements that can be made. First, we make sure the water channel is level and stable before starting the experiment. Okay, then we need to wait until the water is stable before taking any measurements. We should also read the measuring scale at eye level to reduce human error. Last but not least, repeating the experiment several times and using average value can improve the accuracy of the experiment. For the discussion, the result shows that the V1 is higher than V2. That means the water is slowing down after the hydraulic jump. Then the Froude number is decreased because it shows the flow change to the stable conditions. Lastly, the energy loss confirm that the hydraulic jump dissipate energy through the turbulence and water force. Overall, the consistency of the result shows that the experiment follow the hydraulic jump theory. For the preparation, first of all, we need to measure the water depth carefully to avoid any errors. Next, we need to measure that the flow is steady before taking readings. For SDG related, we have DG6 and SDG9. For DG6, the improvement of water management to reduce the erosions. For SDG9, the design for the safe hydraulic support structures to make sure that the spillways and canals perform smoothly. We have come to the conclusion that the hydraulic jump experiment was successfully carried out and achieved its objective. Through the experiment, we gain a better understanding of how water flow changes from subcritical flow to supercritical flow. Overall, this experiment gave us a better understanding on hydraulic jumps and their importance on hydraulic engineering. That's all.